Actually, I'm going to ask you just to take a break from me listening to me the whole time. 41, A to D. See if you can, which ones you can answer. I'm quite confident that you could probably answer quite a few. So on page 41, where it says password containing 3 digits followed by 4 letters, how many passwords could you create? Just give it a try before I get it going. All right. Good work, guys. A password consists of 3 digits followed by 4 letters. How many passwords can be created? We're assuming we have 26. We're assuming, if it doesn't say otherwise, we have 10 digits, right? That's standard. But I will, on a test, tell you exactly what's at play here. Without restrictions, so we have 1, 2, 3, right? 1, 2, 3, 4. It's essentially 26 to the power of 4. So repetition, everything is allowed. This is probably the quickest way to enter it into a calculator. That ends up being 456,976 followed by 3 zeros. So 456 million. Passwords, add some kind of unit to it. Combinations, passwords, you name it. Okay. No repeating letters. So we would just go 10 cubed, right, times. You can go 26, pick 4, right? You can write it like that if you'd like. It's up to you. 4, right? 1, 2, 3. 1, 2, 3, 4. Right? It's 26, 25, 24, 23, 10, 10, 10. Right? So they're both saying the same thing. Regardless, you get, where am I here? 3, 5, 8, 8, 0, 0, 0, 0, 0. Yeah, these calculators are not very good at, like the commas would be nice, especially when it's a bigger number, to get the right number of zeros down. And here it is. This is the one. How many passwords have at least one repeating letter? The word at least is the giveaway, at least one repeating letter. So I'm going to use indirect reasoning here. Instead of finding all the possible ways to get repeating letters, which would be quite a task, I should say. It would be quite a task. You would need pages to do that. I will take this approach. Total without restriction minus no repeating letters. That's my approach here. If I take away the ones that have no repetition, no repeating letters, I may add no repeating letters, which I do have in B, then I will actually get my answer. So I'm going to go 10 to the power of 3 times 26 to the power of 4, just to show you that this is an A, minus 10 to the power of 3 times 26, pick 4, and now I'll write down the numbers because I know most of us like the actual values, right? So if you subtract the ones that have repetition, no repetition, all these passwords that we've created in B do not have any repeating letters. We've made sure of that the way we count it. So I'm taking them away from the total possible, and here it is. I'm looking, making sure I get the right number. And that's what you're supposed to get there. So all of these passwords, what does it mean at least one repeating letter? Right? It could have 1 repeating, it could have 3 repeating, it could have multiple combinations. All of that is in here. Okay, that's what this is what indirect reasoning. You take away what definitely isn't, then you're left with what is. It's almost like 40% chance of rain. Well, that means 60% chance that it's not going to rain. It's almost like you look at it from a different perspective, okay? At least one repeating number, how would you do that? I will go total minus no repeating numbers. That's how I'm going to approach this one. Let me zoom into that part right there. Total, I already know it's 10 cubed 26 to the power of 4. Minus. How do I do the no repeating numbers part? I will go 10, pick. Let's go back up to my setup. I'm picking 3, right? Times 26 to the power of 4. Because the letters, I don't care right now. The letters could stay repeated for all I care. Okay. So that's how you would set it up. Let me give you a visual. 1, 2, 3. 1, 2, 3, 4. Some of you might benefit from this, so why not? And here it's 10, 9, 8. This is the 10 pick 3 part. So we're going to go 4, 5, 6, 9, 7, 6, 0, 0, 0 minus, I'll figure this out. I'm going to look at my key here. 329, 022, 720. There we go. And here's my answer. And that's an incredible number of passwords. However, right, with the super computers out there and AI, they can still often crack your code because they just try every single one. That's why their passwords are getting longer, and that's why you have the two-step verification, right? It makes it even harder to break in. Can I do one more? This one right here, multiple choice quiz, because a lot of you have multiple choice in like the sciences, right? You've got tons of multiple choice there. Of 6 questions, there are 4 options per question. That's very important. It's not just true false, it's actually you've got 4 options. How many outcomes involve getting at least one question right if all questions are answered randomly? Here's that getting at least one question right. I'm going to break this down. Total possible ways of answering. How many questions are there? 1, 2, 3, 4, 5, 6. How many options do you have? 4. Every single time you've got 4 options. That's why guessing is not a good idea, right? So that's 4 to the power of 6. That's 4,096 ways that you could possibly answer. If you randomly just go, you get another test, let's go randomly again, right? There's this many options. Now I'm going to figure out all wrong. Let's get rid of the options where you get every single one of them wrong. So we go 1, 2, 3, 4, 5, 6. About to go. It is about to go, but we'll finish this one. How many wrong ones are there in the first one? How many wrong options are there? Second one? This is classic. This is a classic, right? Coins, multiple choice questions, classic. So that would be 3 to the power of 6. That would be 729 ways to get them all wrong. Okay, so at least one right. You go 40, 96 minus getting them all wrong. Get rid of the ones where you get them all wrong. Because everything else, you will have at least one of them answered right. At least one of them you have right. So you have 3,367 outcomes.
That means if you were to randomly guess, you'd have a 0.0002% chance of them all right.
Yeah. And that's next unit. You went 1 over this, right? 1 divided by 4,000. Yeah. Okay, thank you guys. What's your homework? I would say start reviewing for your test. Beef up your study sheets. Maybe look at the handout I just gave you. Do questions you haven't done before. Try some equations. Look at the quiz. Did you get the equation wrong? Try that one. Did you get the paths wrong? Try that one, right? Focus on those and you'll be all right.